Stoichiometry. Stoichiometry is the chemical process or chemical concept that we use to quantify reagents needed, products produced, ideally when a chemical reaction occurs. So this is an example of a stoichiometry question where you have methanol burns in air according to the equation. A reminder that how you read chemical equations. You have 2 moles of methanol react with 3 moles of oxygen to produce 2 moles of carbon dioxide and 4 moles of water. If 209 grams of methanol are used up in the combustion, what mass of water is produced? So conceptually, stoichiometry problems have this is a typical workflow where you're giving a mass of some chemical, let's just say some chemical A. You must convert it to moles of A. Then you convert from moles of A to moles of B. And then back to grams, but this time grams of B. Make this a little smaller. Get it all in frame. But that is an example of a typical stoichiometry problem. So what we're given in this problem is a mass of methanol, and then it's asking for a mass of water, a product. It could be a mass of anything in the balanced chemical equation, but the process that's observed or utilized is the one that's mentioned. So to get from mass to moles, you use molar mass. To get from moles to moles, you use the correct molar ratio. So molar ratios are determined from the molar coefficients in the balanced chemical equation. So you use the correct molar ratio to get from moles of A to moles of B. And then you use the molar mass of your chemical that the question's asking about to get back to grams of the product or whatever the chemical is asking for. So in this example, we have 209 grams of methanol. So CH3OH. So we have to use the molar mass of methanol. Okay, so the molar mass of methanol, 1 mole of methanol is equal to 32.04 grams. Clean that up a little bit. So this is an equality from dimensional analysis. This can be arranged where the mass is in the numerator or the denominator, the mole is in the numerator or the denominator, and which one we use is based upon the unit. Okay, so we've got grams in the numerator for 209 grams. So that means that we have to have grams in the denominator to get grams of methanol to cancel. So we get grams of methanol to cancel. Okay. So next in the workflow, moles of A to moles of B. In our question, moles of methanol to moles of water. So the molar ratio that's correct to use is we've got 2 moles of methanol per 4 moles of water. And that can be used as an equality. It's a ratio, but we can use that for our workflow. And then how we decide what goes on the top or the bottom is getting the units to cancel. So we've got to get units of methanol to cancel. So methanol, moles of methanol will go on the bottom. Whoa. Sorry about that. Per 4 moles of water. Zoom everything into frame. Now that everything's in frame, moles of methanol cancel. And then last in the workflow is to go back to what the question's asking us to solve for. So mass of water. So we must use the molar mass of water, which is for every 1 mole of H2O, it weighs 18.02 grams. That's the equality. Again, getting our units to cancel, 1 mole of H2O of water, go in the denominator on the bottom, and then that weighs 18.02 grams. Okay. And we're left in grams of water. So grams of H2O, that's what the question is asking us to solve for. Now it's a matter of plugging in the numbers and solving. If I do the math correctly, then our answer, plug in all of that math, should be 235 grams of water.